Hi, welcome to another video with Mr. Wise. In this video, I'm going to be talking about the trophic pyramid and trophic levels. So, uh, first thing, when the trophic period, essentially, the interaction of biological communities characterized by the manner in which food energy is passed from one trophic level to the next along a food chain. So, when we're talking about trophic levels, we would see that, say, this level here. Oh, sorry. Uh, this level here would be the first level, and then this one would be the second, this one third, and then the next, the fourth, would be essentially your trophic level: first, second, third, and fourth. Now, in the first trophic level that we're having down here, there's a name we give them, and so we call them the autotrophs. The autotrophs. See, the reason they're called the autotrophs is because they're the ones that produce their own food. They're the producers. Plants bring in through photosynthesis, they bring in solar energy to make their own food. They autotrophs. They auto make their own food. Past that, they're what's called the heterotrophs. And this is what you call the rest of them for the rest of the levels. The primary consumers, secondary consumers, tertiary consumers. These are all called heterotrophs, because they either directly or indirectly depend on the primary producers for food energy. So what we're going to see in this this image down here in the bottom left corner, we can see that there's energy flowing through the system. So first you have the producers with the large amount of energy, and then the energy lost from the system. So as you move up, more and more energy is being lost to the system, essentially, through heat of some kind. This is what they call the first law of thermodynamics, where energy will be lost to heat through the system. So what's happening here is the producers lose some amount of heat, and then as you move up, you're losing 90% per level to heat of how much energy is being produced. So, the primary consumers will only have access to 10% of the energy that the producers did. The secondary consumers will only have 10% of the energy the primary consumers had, and then the tertiary consumers only have 10% of what the secondary consumers consume. If you want to visualize that, we can look at up here in the top level here. So it shows here the producers produce 10,000 kilocalories of energy in the system. So heat is lost through the system somehow. Usually it's through animals lose heat through basic biological functions like digestion, and to warm your body is where you're losing that heat from. So 90% of those kilocalories, that energy, is lost. So the primary consumers only consume 1,000 kilocalories. Now you go up one more trophic level. The snake eats the rabbit. He's only consuming 100 kilocalories of energy, 10% of what the 1,000 was. Now the eagle eats the snake. Well, the eagle now, he's a tertiary consumer. He only gets 10 kilocalories. So each level, you only have 10% of the energy available, is what's happening. So we're just going to look at this graph here. So usually in a food web, which is what this is, there's usually about 3 or 4 levels depending. This one is slightly different than what we normally see. So normally what we see, say, on land, the producers are always plants, essentially. They're the ones that take in the straight energy from the sun and produce food. So they are producers. But in the ocean, it's actually a little different, depending on where you are, depending on the ocean. You have these phytoplankton, and the phytoplankton they take geothermal energy from the earth, essentially, that gets exuded into the ocean from underwater vents, and they take in that energy. So they are the producers in there, essentially, of energy. So as we move up level from phytoplankton, you go to zooplankton, like shrimp, which eat the phytoplankton, and then you get to smaller fish that eat the zooplankton. Then you get larger fish that are predators that prey on the smaller fish, like squid or mackerel or something, and then you get the top predators like sharks, great white sharks, smaller sharks, marlin, stuff like that would be the top. So each one of these levels, you're losing 10%, or sorry, 90%. You only have 10% of that energy available. So because you only have each level, you're losing that much energy. The top the top predators need to consume more energy. They need to consume more animals, essentially more biomass, in order to get the energy they need. So eagles having to eat a lot more biomass than what a rabbit has to do to get the same amount of energy, because the rabbit is getting the energy directly from the producer. So not as much energy is lost to the system. So in terms of relative scale, you're having to eat far more biomass to the top predators to gain the same amount of energy. And this concept is going to be very important going forward when we talk about biological magnification and or bioamplification, however you want to call it, bioaccumulation, many words for it. But we're going to be looking at that, and that's a very important concept to understand when we talk about the trophic levels and the losing of energy to the system. It's a very important concept. So yeah, that's this video. Thank you for watching.